Hello, it's been 30 seconds. Let's just do the second one. All right, no shoutouts this time. All right, it's literally the same type of problem, but let's go into it. So, we're looking for the voltage of each light bulb. So, light bulb 3 is by itself, right? It's not sharing the current with anybody like these two are. So it's selfish. It wants all the volts to itself. And we know by the time it completes the circuit, it needs to be at 0 volts, right? So what plus 0 equals 9 volts? Obvi 9. So light bulb 3 is going to have 9 volts. And like the last one, these two are sharing, and so what plus what equals 9, but they have the same resistance, so it's just going to divide by 2. Okay? So now for the current. Let's find the current here. V equals IR for the third light bulb. Our voltage for the third light bulb is 9 equals X times the resistance, which is 5. These two numbers are too far apart, so they need to take a plane. 9 divided by 5 is 1.8. Okay, let's do so let's do the red arrow. So here, so let me just check. Okay. So we can add these resistances together to get 1 and 2. Or we could just do 1. So the resistances are the same, so the current is going to be the same as well. So 4.5 equals X times the resistance. Divide, because they're too far, you need to take a plane. X equals 0.45, right? Yes. He rounded up. That's my vision board. He rounded up, so he did X equals 0.5. Okay? Now, we know that our currents here and here have to add together. So 1.8 plus 0.5 is 2.3 amps. And what goes in 2.3 must come out 2.3. And that's it for this one. Should we keep going? I would love it if this loaded. Okay. Okay. You're seeing the background. Let's go into this one. Let's go into this one. Problem 4. Okay, so he's looking for the voltage of each light bulb. Okay, Stick with me. Stick with me. I'm tired. I'm poop diddy scoop diddy. You're poop diddy scoop diddy. We're all poop diddy scoop diddy. Okay? We're all trying to figure it out. So, when we think about when it completes the circuit, it needs to be at 0 volts, right? We don't have as much information, but this light bulb has a resistance and a current already. So for number 2, V equals IR. V, we don't know it yet. Our current here is 0.8. Our resistance here is 5. These numbers are close together, so they can just multiply. 0.8 times 5 is 4. So our voltage for light bulb 2 is 4 volts. So voltage 2 is 4 volts. Now what we said, how when it completes the circuit, it needs to be at 0 volts, right? So this path, they're sharing the current here and here. So what plus 4 equals 12 volts? So 12 minus 4, 12, 11, 10, 9, 8. 8 plus 4 equals 12, right? 8, 9, 10, 11, 12. Yeah. Right? Yeah. Okay, so then voltage of 1 would be 8 volts. And then for the third one, these are sharing a current as well. So what plus 8 equals 12? It's 4. So then our third one, oh my gosh, is 4 volts. Okay, so now let's find our currents. Let's find our current for 1. V equals IR. Our V is 8 equals, our current is X. Our resistance is 5. See? These numbers are too far apart, so you need to take a plane. 8 divided by 5 is 1.6. Okay, let's do number 2. V equals IR. Our voltage for 2 is 4 equals our current, which is an X, and our resistance, which is 5. These numbers are too far apart. You need to take a plane. 4 divided by 5 is 0.8. And let's do the third one for kicks. V equals IR. Our voltage for 3 is also 4. Our current, we don't know it. And our resistance, which is 5. Again, these numbers are too far apart. Take a plane. 4 divided by 5, X equals 0.8. Now, why did I do all 3 of them when I know that the resistance, blah, 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 blah. Why are you doing more work? Because I want to check my answers. Because this main current here, before it splits off, right here, this has to equal this one plus this one. And 0.8 plus 0.8 equals 1.6. And I wanted to check my answer. And that's how you check your answer, okay?